Hello, my fellow 340 classmates. I'm Josh Felger. Me and my teammates, Andy Ho and Yaitel Zhang, will be giving you a presentation on a buck converter. This assignment is for Kate Davis's ESIN 340 class at Texas A&M University for the fall of 2019 semester. Let's jump into it. So what is a buck converter and what is its purpose? A buck converter is a DC-DC step-down power converter. It steps down the input voltage to the output voltage. As you can see in the figure to the right, a typical buck converter consists of a DC voltage source, a switch, a diode, an inductor, and a resistor and capacitor in parallel for the output. The output voltage is controlled by the ratio of Vn in the duty cycle. I will now hand it off to Andy Ho to explain more about that.
The buck converter has two states, the on state and the off state. In the on state, the switch is closed and your voltage source is directly connected into your circuit. The voltage source provides the current which goes through the inductor and into your load. However, in the off state, your voltage source is disconnected from your circuit and all your current goes through the diode and your inductor. And mainly, the buck converter's voltage output is determined by D and Vn. D represents the duty cycle and Vn is your input voltage. At a higher D or duty cycle, your voltage output will be similar to your voltage input. However, at lower duty cycles, then you would have a lower voltage output and therefore higher current in your output and lower current in your input. Following that, here are the waveforms represented the buck converter. Each phase has an on and off stage, and it will repeat until the circuit is disconnected.
The application for buck converters includes a wide range of electronic devices. On the low power end, we have small power electronics. For example, USB Type-C converters, which must use the buck converters to reduce the voltage provided by the USB port, which is 5 volts, down to 3.3 or 1.2 volts in order to power the adapter controller chip inside. When we go up in power, we have the battery chargers. The most common laptop adapters provides 20 volts as input voltage, but most laptop batteries are only rated for 8 volts or even less, which means that we need a buck converter to step down the voltage from 20 volts to somewhere around 7.2 volts to be able to charge the battery safely. We keep going up in current. We have the voltage regulation module for processors. For example, CPU, GPU in your laptop, desktop, or even in your mobile phones. In desktops, the power supply unit generates 12 volts DC voltage, while the processors requires 1.2 volts. At such a low voltage, they require an insane amount of current in order to maintain normal operation. We are talking about hundreds of amps. A single buck converter can't really handle such a high amount of current. That's the reason why we have multi-phase VIM designs, which consists of multiple buck converters with their PWM controlling signal out of phase with each other, so that increases the effective switching frequency by decreases the switching frequency on MOSFET. As a result, it reduces the output ripple and decreases switching loss, which is ideal for high current, low voltage applications. That's it for the buck converters. Thanks for your time. Don't forget to vote for the buck.